Alright, in this video we're going to go ahead and cover another projectile motion question. This one's a little bit different. A football kicker is attempting a field goal at 44 meters out. The ball is kicked and just clears the lower ball with a time of flight of 2.9 seconds. If the angle of the kick was 45 degrees, what was the initial speed of the ball, assuming no air resistance? Alright, so for this, what makes this one a little different is we're not actually calculating y. In this case, we're calculating x. And as we've covered, excuse me, as we've covered, y is independent of x. So let's go ahead and look at this. Well, right away you should be thinking of the formula x. Oh, got my eraser out. That's not what I want. Got my eraser out. So let's go ahead. Okay, right away we know that x is going to equal v naught times t plus 1/2 times acceleration times squared. And there's something quite nice about actually working with x here. Well, first of all, let's draw what we're actually talking about. So here's our get a better position. Okay. I'll have the tab a little more centered. Okay. We have a little x and y plane here, right? And you really don't need it in the negative, as we know there's a ground, you can't really go negative for this example. So we know that the ball, 45 degrees, in that direction, and he's 44 yards out. Alright. Sorry, meters out. Important to write down our units so that we don't forget. Alright. So right away, something that's quite interesting is that our acceleration equals 0. We have no acceleration. So that's going to delete this whole part of this equation. And now we're left with x equals v naught times time. Well, time is given to us. You know, it's right here. We have 2.9 for time. Now, what else can we know? Well, we know distance. So we know x equals 44 meters. So we really are just solving for v. We don't know v naught. Now, we do know something about v naught, however. We know that v naught is going to be correlated to cosine. And the reason we know this is because whenever we're trying to figure out something like that with respect to the angle, whenever we're adjacent to the angle, we're going to use cosine. If this was on this side, if we were trying to figure out for y, this would be sine. Or if we had gotten the angle on this side, this would be sine. But in this case, we're using cosine because it's adjacent. And if this still doesn't make sense, just remember the old term. So, toa, and you'll know what to use then. Because, for example, in this case, we're using cosine because we have the adjacent to the angle and we're working with respect to the x. So this really just becomes x equals v naught cosine theta times t. So let's solve for v. Well, in order to do so, we would divide by cosine theta times t. Give me that. Bring it over to the other side. And now you would plug in these values that we have here into our formula. So this would actually get you 44 divided by cosine theta times, or not theta, because we actually know the angle. It's 45 degrees. And that would all be time 2.9. And that's going to equal your velocity, your initial velocity at least. So now let me go ahead and grab a calculator. On the other way, on the other side of the tube. Alright, let's go ahead and do 44 divided by cosine. Let me actually add parentheses there. Cosine of 45 degrees times 2.9. And that should get us 21.45, which gives us an initial speed of 21.45 meters per second squared. Or sorry, no, not squared. That's that would be velocity. I'm sorry, that would be acceleration. Looking for velocity here. There you go. And that gives you the complete responses to that question. This video helped you guys out, and thanks for watching.